Hello everybody, in this video we are going to solve a system of equations using the elimination method. So one of the things that we need to do in order for us to be able to use the elimination method is to be able to create a zero. The only way we can create a zero by adding and subtracting is to make sure that the numbers that we're combining are the same but have the different signs. So an example would be a positive 2 and a negative 2. If I combine those two numbers, it will create a 0. A positive 6 and a negative 6 would create a 0. So we need to be able to create a 0 to eliminate a variable and be able to solve a system of equations. So let's look at some of our examples so I can show you how we can create those zeros and use the elimination method to find a point of intersections. So the steps that we're going to use, we're going to make sure that both of our equations are in standard form. If we're missing an x or a y, we can insert a 0 placeholder to hold its place. We're going to stack both of our equations one on top of the other, so that way our x's and our y's are lined up and we can actually add and subtract vertically instead of horizontally. We are also going to make sure that before we start adding and subtracting, one of our variables has the same number but opposite signs, so it can create a 0, because that's the main topic that we're going to have to do for elimination. And then once we do that, we'll combine like terms. We should be able to solve for the opposite variable and then use algebra to go back and plug them in and find the missing variable. So with that being said, let's go ahead and look at our first example. So when we're doing the elimination method, we're looking vertically. We're looking at our x's in both equations together. We're looking at our y's also together. And we're going to try to determine which one of these can create a 0. And if we can't create a 0 at the beginning, we might have to manipulate the equations to create the 0. So if you're looking at this one right here, the first thing we're going to do is compare the two x's. We have a negative 4 and a positive 4. If I were to combine these, they would create a 0. So this one is already ready. So how do we use the elimination method and the 0 to solve this equation? The first thing I'm going to do, hello everybody, in this video we are going to solve a system of equations using the elimination method. In order for us to be able to use the elimination method, we need to be able to create zeros. The only way we're going to create zeros is by having the same number with the opposite sign. So a couple examples would be a positive 3 and a negative 3. Those two numbers would create a 0. A positive 8 and a negative 8 will also create a 0 because they are the same number, opposite signs. So let's go ahead and see how we can use that to solve a system of equations. So if you look at the top, I have a couple steps. So in order for us to be able to do the elimination method, we do need our equations to both be in standard form. If we're missing a variable, we can use a placeholder 0 to hold its place. We're going to make sure that both of our equations are lined up and stacked one on top of the other. So notice that they're already like that because our x's and our y's are directly on top of each other. And then we're going to look at both our x's and our y's to make sure one of them will create a 0. We need them to have the same number but opposite signs, a positive and a negative. And from there, we're going to combine like terms and solve for whatever variable is left over. So let's take a moment to look at our examples right here. We're going to start with this one. So the first thing I'm going to do is make sure that they're both stacked. I have two x's, I have two y's, then my equal sign and my constant. These are already ready. And now we just have to look to see, does it create a 0? So instead of adding and subtracting horizontally, we are actually going to combine our like terms in both of our equations vertically. So if I'm looking at my x's, I can see that the first x has a negative 4, the second x has a positive 4. If I combine these two x's, it will create a 0. So this one, we don't have to do anything except combine like terms. So I'm going to go ahead and highlight those. You can circle them if you want to. But remember, these are the ones that are going to eliminate because they're going to create a 0. So I'm going to draw a line because I'm going to combine these vertically. We know negative 4 plus 4 gives us 0. There is no need to write 0x or anything because they eliminate. They cancel each other. All right, so if we look at the second example here, you're going to notice that once again, our x's are lined up, our y's are lined up, and so are our constants. But this time when I look at my two x's, I have this negative 9 and this positive 10. That will not create a 0. But look at your y's. You have a negative 6 and a positive 6. So we know that they're the same number, opposite signs. They are going to create a 0. So I'm going to highlight those so you can see that that's where our 0 is going to happen. That's where the elimination is going to take place. So because they are already ready, let's go ahead and combine our x's. Let's combine our y's and our constants. So if I have a negative 9 and I add 10, it's going to give me 1x. Negative 6 plus 6 gives me 0. There's no need to write down 0. There's no need to write down y. We don't have to write anything because it's 0. Bring down your equal sign. Negative 24 plus 24 does give us 0. So I'm going to write that down because this is our placeholder. We just can't have an equation with a blank on one side. So from here, we know that x is equal to 0. You can also divide both sides by 1, but I'm just going to write x is equal to 0. Our answer is an ordered pair. So now that I know that x is equal to 0, I need to find the y value that goes with it. So because the last time we picked the second equation, let's go ahead and plug this into the first equation. It does not matter which one you plug it into. So for this one, we're going to say negative 9. Instead of x, we're going to say 0 minus 6y is equal to negative 24. This becomes 0, so I'm not going to write it down. So I have negative 6y is equal to negative 24. We're going to divide both sides by negative 6. So that gives us y is equal to positive 4. So not only did I have my x value, I now have a y value. And I can write this as an ordered pair. So my final answer here is going to be 0, 4, because our x, y is the answer. So if I were to graph these on a coordinate plane, I could see that both of these lines will intersect at 0, 4. And that's what we're looking for. All right, let's look at one more example that requires a little bit of work. All right, so as you can see, we have two problems down here. Let's look at this one. And one of the things that you're going to notice is, yes, they're stacked. We have our x's, we have our y's, and our constants. They're lined up and ready to go. But one of the things you're going to realize is that, yes, the x's have the same number, but 2 plus 2 gives us 4, not 0. So we have a problem here. One of these 2's has to be negative in order for it to create the 0. Now, I don't want to jump over to the y's because there's nothing to do with the y's, nor are they the same number, but none of them are the opposite sign either. So my suggestion is if we can get one of these two to be a negative 2, then they will combine and form a 0. So we can actually take a whole equation and manipulate it. The only way we're going to have to do this is because we want to keep the number the same, we're going to multiply by 1. But because we want to flip the sign, we're actually going to multiply by negative 1. Now, I can't just multiply the 2. I have to multiply all of these numbers, or it won't work. So negative 1 times 2 is a negative 2x. Negative 1 times 7, negative 7y. Negative 1 times negative 29 is a positive 29. Now I have exactly what I need. I have two numbers that are the same, but they are the opposite sign. So this will now become 0 because one's positive and one's negative. I'm going to draw my line. This becomes 0. I'm just going to leave it alone. 5 minus 7 is a negative 2y. is equal to, and if I take negative 15 and add 29 to it, it is going to give me 14. I have an equation I can solve for y, so let's divide both sides by negative 2. And we get y is equal to negative 7. I have a y, I need an x to go with it. It does not matter which equation you use to plug it back in, but I am going to advise you that it's probably best if you use one of the original ones. Not the one that you created, but use the original. So because we multiplied the first one by negative 1, I could use that one if I wanted to, but I'm actually going to use the second one. And remember, it does not matter. So from here, we're going to say 2x plus 5 times negative 7 is equal to negative 15. And from here, I can multiply 5 and negative 7 to get negative 35 is equal to negative 15. I'm going to add 35 to both sides. So that's going to give me 2x is equal to 20. Divide both sides by 2, and we get x is equal to 10. So now I have an x and a y. I can write it as an ordered pair. So this is going to be 10, negative 7 as my final answer. So we're going to take a moment to talk about this one right here. Notice there are going to be several ways that you can work these kinds of problems. But one of the things that I'm going to point out is the ultimate goal, as long as you can get one of your variables, whether it's the x or the y, to be the same number but opposite signs, it doesn't matter which one you use. So what I'm going to point out right here is I can get 2 and 3 to become a 6, but I'm going to have to multiply the first equation by 3 and the second equation by 2. To get a positive 6 and a negative 6, so the x's can cancel out. Now, some people in class pointed out, well, we can multiply 3 by negative 2, and that will create a negative 6 up here that will combine with that 6. So let's do that. We're going to multiply this by negative 2. Now, if you decide to do this a different way, that works perfectly fine as long as you have the correct ordered pair at the end. We're going to multiply all these numbers here by negative 2. So if we do that, we're going to get a negative 4x, a negative 6y, and I'm going to say that this is going to be a positive 34. So if you multiply negative 2 times a negative 17, it's going to give us a positive 34. From here, you're going to notice that your y's will eliminate because one's a positive 6 while the other one's a negative 6. Once you do that, you should be able to get x, plug it back in, so you can then find y. I'm actually going to pause right here. We have a couple of problems that we need to work on the back, so I will see you in the next video.